Today, we're going to continue our journey into SQL Joins. That is the merger of more than one table's worth of information into a single data set. So we'll take a look at some example data. We'll munge that data, throw that data into a database, into two different tables, and we'll look at how you can then combine those two sets of data from two different tables into singular actionable data. I'm going to take the data set from New York City jobs. Every job that is available in city government is posted to a portal called the NYC Data Portal. Let me pop that open so you can just take a look at it. But anyway, so there's a lot of interesting information about New York. And one of those is this jobs data. So what does it show us? We can actually go and look at it. So let's view the data for a second. What you have here, each job has an ID. There's a certain agency within city government that each job belongs to. Posting type, I guess there are some internal jobs, external jobs that they only advertise externally or only advertise internally, I guess. How many of each position are available? So a lot of housing authority people are available, housing assistants. And business title, this is, I guess, just a variation on the job title. See, they seem to have a couple different job titles. I don't understand exactly why, but business title is some sort of title of the job, but also there's some other way of titling that job, I guess. The interesting stuff that I'm going to jump into is salary range. This is, of course, many people's concern. You know, what is your bottom salary in that job and what is your upper salary in that job? So every city job has a range. You know, if you're the most qualified candidate who gets a job, then you might expect to get closer to the upper bound. If you're an entry level or don't have all the experience that people would like, you might get lower on that range. So that's pretty typical of public companies and government agencies, that they have fixed ranges of salaries. Same in public universities. They have ranges of salaries that people get. In our private university, we don't do it that way. There's not as much transparency. All right, so what else? Job description, blah, blah, blah. You can look through this yourselves. Okay, so that's the basics idea. We've got each job, which agency it belongs to, what kind of salary range we're talking about. That's the stuff, those are the columns that I'm going to be focusing on, just for a simple example. All right, so what we're going to do is we're going to take that file that they give us and export it as a CSV. So you can go to the export button on any of these data sets, and CSV is all you need, and pop that open into a directory and you've got their data. So I've already done that, but you can, if you want, poke around and download that data. You'll get a CSV version of this file. What I've written is a not very beautiful Python script that I've given you, and you can use it to munge that data. So if you click and download this Python script, dump it into the same directory where you download that data, you can then run that Python script and it will output two files for you. What I'm doing in that Python script is just munging the data and breaking it up into two separate files. Remember, our goal today is to do joins, is to do two data sets and show how you can merge them together. So I'm taking this excuse to just split these into two different files. What do you get in those two files? I've already got them, so let me just show you. If you ran that script, you would generate these two things, jobs.data, jobs_data, and agencies_data. But let me just talk briefly about why I split this into two. It's not a very good reason. I just used it as a cheap justification for getting two different tables, but let's take a look at what I thought was a good reason for this example. I thought that they are keeping records about two things here. The records they're keeping are about jobs. That's primarily the purpose of this table, is to indicate information about jobs, the title, and so on, and all that stuff. They also seem to have information not really about the job, but about the agency that you're working in. So they do have the name of the agency. And I think, although I'm not 100% clear, and I just guess that maybe this is the case, that these locations are actually agency offices. Yeah. So it's not really about the job that this is at 80 Maiden Lane. It's about that agency that you're going to be working at is at 80 Maiden Lane. So I thought that they're keeping records. And again, I'm just assuming that's correct without doing any further research, because I wanted to believe it's correct so I can split this in two justifiably. But I made the argument to myself, perhaps incorrectly, that they're keeping data on two different things, jobs and agencies. There's a relationship. A job is within a certain agency, But in the world of normalization, which we'll talk about, you want to have your tables focused on one single entity, one single thing. And a job is a different thing from an agency. There's a relationship, sure, but they're different things. And if you're keeping information about jobs in this table, like the salary range is certainly about the job, but also keeping information about the agency, like the location, the website of the agency, whatever else you might think of about an agency, well, then you're keeping information about two different entities in a single table, and that breaks the rules of normalization, which we'll go through at a later date. So I convinced myself that agencies and jobs, different things, they need their own tables. So that's where I got to. So again, it's about how many different entities are you storing information about, and making sure that each table is about one singular entity. So what I ended up with in my script, if you run it, is an agency's CSV file. And really what this is an ID number for every agency, an ID number for every agency, 0, 1, 2, 3, and so on, and a title of that agency. I'm not interested in the location of the office, so I just chopped that out of this data set. But in another world, we could have kept that in here as well. In the jobs data, which is separated out, I've got ID numbers for every job. These are my own ID numbers. Now, why did I make my own ID numbers when they have their own ID numbers in the data? If you look at their data, which I have done previously, you'll notice that there are multiple records with the same job ID. So here's an example of a job which is a maintenance worker, but it's an external posting. And here's the same job, maintenance worker, but internal posting. Don't ask me why. Government is government. They have all kinds of weird reasons why they might do this. But they've got the same job listed multiple times in many cases. And it's not always internal, external. There are other cases as well, I think, in this data set. The job IDs are not unique per every row. I cannot, in my database, use non-unique values as my primary key. Remember, the primary key is the main sort of unique aspect of every record that you're guaranteeing will be unique. So when I say go look up job number 132292, it better be one record with that ID, or else I can't use that field as my primary key. So we've got non-unique values in the job ID, and you need to find a different key for a primary key because these are not unique. And there's no other field here that I think is unique. All these other ones are shared among multiple rows. So I had to make a new kind of a field for my primary key value. We call that, technically speaking, a surrogate key. It would be nice if a key that makes sense in the data is usable as a primary key, but when that's not the case, we make just an arbitrary number, 1, 2, 3, 4, 5, for unique keys. That's called a surrogate key system. That's what we most often do. So I've got these two data sets. Agencies is just about agencies. Remember, we keep it about one entity, one noun, and jobs just about the job parts. And I cut out most of the fields that I wasn't interested in this example. Again, I'm trying to keep it quick and fast and simple. So I'm just focusing on the name of the job, the salary range from, the salary range to, which agency it's in. These are the actual ID numbers of the agencies as I have ID'd them in the other CSV. And this is the job ID. That's the way the government thinks about this job. And this is my own personal primary key for my database. So I've got these two files. We don't need the original NYC jobs anymore. I've got the jobs information I'm interested in this one, and I've got the agencies in there. But the key point I wanted to make was each agency I've assigned a unique ID in my CSV. And in the jobs CSV, I'm indicating which agency each job belongs to by referring to the primary key of that other table. And we will be putting these into databases in a second. So for example, where this housing assistant job is in agency number 1, as indicated here, we can go here and look up agency 1 is NYC Housing Authority, right? When this one says it belongs to agency number 3, confidential investigator, that sounds good. We can go into Department of Investigation and understand that that's the agency that particular job. So there's a relationship, right? The table here has references to rows by their unique primary keys in this other table. That's the secret to joins. We're going to have established relationships worked out between these data sets, and those relationships have to be embedded within the records. And so that's what we have here. This is what we call a foreign key. The primary key of this row in this table is 3. The primary key of this row in this table is 4. The primary key of this row in this table is 5. These are the IDs of this table. But these other IDs that represent IDs, primary keys of another table, those are called foreign keys. And I have slides about this, but that's the big picture idea here. So let me go through my slides and make sure we go through this progressively. All right, so what I'll do first is make a table. This is a common technique to say, if you've already made this table, delete it. So if you want to try this multiple times, if you're getting it wrong, you can just say drop table if exists, and that'll get rid of any previous version of the jobs table that you've made. And I'm going to set up a table called jobs, which is going to have an ID field as the primary key, a job ID. Remember, that's NYC's government way of identifying jobs, which is not useful to me, really. Agency ID, remember, that's a pointer to the ID number in the other agencies table that will hold the agency's information. The title of the job, the salary range from, and salary range to. So if you run this code in SQLite, I'll just show you, don't feel like you need to follow along. I'll pop open my editor. I'll say SQLite 3, and I'll make a database called jobs.db. And now I'm in SQLite. And I'll paste in that little script to create that table. And hopefully this works. And hopefully it did. We can check .tables. Yes, there's a jobs. Let's check out the schema, .schema, jobs. And we can just make sure that it got created correctly, which I assume it did. I'm going to now go back to my slide. So we've created that jobs table, and I will then create the other table that is listed right there for agencies. The agencies, I kept the data really simple, just the name of the agency, called title, and the ID, which is a primary key. So let's do that. All right, check it got completed correctly, check the schema in case you have concerns. And there you have it. Everything looks exactly like I typed it. So there we have it. Now let's continue with importing. Now, how do you import data? If you recall, if you're importing data like I am about to do, if I'm importing data that has a primary key field, it has to match the table structure exactly. The CSV structure must match the table structure exactly for SQLite to allow us to import directly into that table. Remember what happens if we have table structures that are schemas that are different from in the CSV from the database table. We have to do import into a temporary table that matches the CSV schema exactly, and then copy into the regular table. I've tried to avoid that by making the CSV match exactly how I want it in the database. In my munging, I added these IDs so I could just import directly into the database table, but let's see if it works. I haven't tried it in a couple days. I might have changed something, who knows. The first thing you want to do, of course, is tell SQLite that you're in CSV mode. So go to so I would say .mode CSV. That informs the database that I want to be thinking about data in the CSV form. And the next command is tell it, just in case it didn't know, that the separator is a comma. CSV mode by default has that, but just so you know, if you had different separators like tabs or semicolons, you could say what the separator is. And at this point, I'm basically ready to import. So I can run the import command. Now you have to, of course, know where your file lives, wherever it is. In my case, I'm in the directory where that file is. So I'll just say .import without any path, just the file name, jobs_data.csv into the table I made called jobs. Now, did it really work? Well, let's take a look at the data. So if I do select star from jobs, let's just show 5 results. Remember, that is a query, a read query, to check out all fields, meaning all columns, in the jobs table, but just limit to 5. So I don't need to take up the whole giant amount of space. And just take a quick look. Does it look approximately right? The primary key looks wonderful. The job ID field looks fabulous. The agency ID is exactly as I said. And the job titles are good. The salary range from, salary range to, all looking fabulous. Let's do the same thing with the agencies. So .import from the agency's data file to the agency's table that I made. No semicolon on import commands. Did it work? Let's just take a look. Select star from agencies, limit 5, semicolon. Simple table, IDs, titles, and that's all. I'm done importing from CSVs. I can change my mode to Markdown, which I think looks nicer in table mode. So if you do, a query that gets you tabular results, if you're in Markdown mode rather than CSV mode, it looks a little more nicely aligned. So it's nicer to read your data, I think, in Markdown. There's also list mode, which has pipes instead of commas. I'm just reminding you of things we've seen. So you might also like that one better. I like the markdown. Now let's turn on the headers so I can see the column names of each field. It would be nice to see that this is the ID, that this is the title of any agency. So I can say dot headers on and do that same query again. And now you'll see the column headings or column headers up there. Primary keys and foreign keys. So again, what we've spoken about earlier, if I look at the stuff in the jobs table again, what I've got here is a little query of 5 results from the jobs table. And what you see is that each column has its column heading because I turned the headers on. Under agency ID, you have the number of the agency of that job. So this table is all about jobs. Certified IT developer applications is in agency 0. Housing assistant is in agency 1. Transit benefit clerk, agency 2, right? They just happen to go in sequential order. It doesn't have to be that way. So that's the way the data is structured. And again, to repeat, this column I'm designating conceptually in my head as a foreign key. That means that these numbers are references to the primary key of a different table. Okay, so we've got the tables imported. We've got the primary keys, the foreign keys, the jobs are associated with certain agencies, and we're all good with that. Now, how do you do the join? How do I find all the jobs in a certain agency or all the jobs with a certain salary range? This is where the queries come in, the read queries. So I might do, let me just do a simple example. Select, let's say, what is the field in the jobs with the title of the job? It's called title. Okay, so select, I'm going to select the job title. And I'm going to select the agency title as well, which is also called title. Bear with me for a second. From jobs, inner join. This is the new thing here. Inner join agencies on, remember capitalization is optional in SQL, on a relationship that I'm going to tell the database that exists. The jobs agency ID is the same as the agency's ID. Now, I'm not done here. But let me just point out one thing, semicolon. There's ambiguity in the way this is written. I want the title field and the title field. What I really mean on a conceptual level, I want to see the job title and the agency title, right? I want to see a list of jobs and their agencies. And I want one to show me, I want that same result to show me both the job's title for any given job and the agency's title for that same job. To avoid ambiguity, like this, you're going to want to prefix the field names with the table that you're talking about. So jobs title from the jobs table and agencies title from the agencies table. So when you get to joins where you're joining multiple tables that might have the same named fields, you have to start to be specific about which table it is you're talking about that field being in. All right, so I'm getting the jobs title and the agencies title, and those are two fields that exist in those two tables, from the jobs table joined together in what we call an inner join with the agencies table on the relationship that the jobs records agency ID, the foreign key that points to the agency's table, is the same as whatever agency we match it to ID field. So again, all I'm doing here is saying the foreign key in the jobs table must match the primary key on the agency's table. And that's how the database knows to join records together. It's going to find any job because I'm searching for jobs. I put the word jobs here first. That means I'm going to look at all the jobs, look at each of their agency ID, and match it up with an ID from the agencies table and join records in that way. So what I'm going to get returned to me, I'll limit 10 just so we can see a couple examples so we don't have a giant scrolling page here. What I will get will be the title and the title. This is title from the job. This is title from the agency. And this job is matched up with its agency. That job is matched up with its agency, and so on, right? So the database has figured out how to match the records up because I told it how. Here's the relationship. The agency ID is a reference to the ID of the agencies table. So we use this word inner join, which means, find the match. We'll talk about other kinds of joins in a second, where the ID that we call agency ID in the jobs table is matched with the ID we call ID in the agencies table. You can look for other relationships, right? I can look for whatever relationship I want. I can look for where the job's title is the same as the agency's title, right? That wouldn't make any sense. There are no situations probably in our data set where the job title matches the agency title, but I can say that there is a relationship and see if there are any records that come back. I have to give the prefixes. I apologize. On that on clause, you can really say whatever you want, but this, I'm showing you the classic case, which is you've got a foreign key, which points to a record in the other table, and you match up the foreign key with the primary key of that other table. That's the classic way you do join. Let me just show you that you could do joins on whatever field you want. Agencies.title. We can look at the highest paid jobs. Select jobs.title, comma, agencies.title from jobs inner joined agencies on. Jobs is always going to be the same. Jobs agency ID is matching the agency's ID. Order by, let's order by the upper bound. Order by salary range 2 in descending order. Limit to just 20 results. All right, so I'm going to get the top 20 paid jobs in this way, right? Why search through LinkedIn when you can just go boom into their data set and find which are the highest paying jobs and apply right now. Tell them you know every possible SQL-based database system, because that's almost true at this point. Let's continue. Okay, so there we go. We've got a bunch of jobs. Chief Risk Officer in the Office of the Comptroller, Computer Systems Manager, Deputy Commissioner of Policy under the Taxi Limousine, lawyers, Administrative Management Auditor. That's surprisingly high paid. Well, we didn't actually see what the pay was. Let's actually select the field, which is going to have the pay information. So I'm going to scroll to the left where we indicate which columns we want to see. And I'm going to add salary range from and salary range to. Jobs, salary range from, and jobs, salary range to. I don't know how that happened, but salary range from, salary range to, from, jobs, inner join agencies. Okay, there we go. Let me zoom out so we can see this a bit better. So here we actually see what those salary ranges are. A very small range here for the Chief Risk Officer, surprisingly small, narrow range. Well, there's a pretty big range on the Computer Systems Manager, from 106,000 to 241,000. That's a gigantic range. I guess that means they're willing to take a relatively fresh candidate in that job if it's the right person. You can make your own conclusions about government here, but there are some big ranges. Deputy General Counsel from 88,000 to 222,000, 223,000. It's a gigantic range. One thing I want to point out before we move on to the other kind of joins. You will not see any records here in our results from an inner join where there is no matching agency. So bear that in mind. All the jobs that we're gonna see in our result set will have a matching agency that it is matched up with. If there was ever a job that had an ID of a record in the agencies table that didn't really exist, it won't show up with an inner join. So inner join enforces what we call referential integrity. The references must be valid. So the foreign key must really point to a real record, or the results won't be included in your result set. Are there any records in our jobs table that refer to agencies that don't exist? I don't know. We just downloaded this. Let's take a look. So how do you do that? Well, if your inner join can't show you missing matches, this is where another kind of join comes in. So let's talk about left joins. Left joins will allow you to actually see missing data. So let's take a look. Select jobs.title, agencies.title. From jobs, instead of inner join, this is where we normally put inner join, we're going to do left join. This is a variety of join called outer join. So there are inner joins and outer joins. Inner joins always maintain referential integrity, which means that the foreign key must really point to a real record in the other table. Left joins don't have that constraint. So we will actually potentially see jobs in this query when I do left join that won't have a matching agency. So let's take a look at that. Jobs, left join, agencies on. Otherwise, the query looks the same. On jobs.agency ID matches the agency's ID. And let's just leave it like that. So we'll see all jobs matched to their agencies like we did before. But if there is an agency missing, we'll still see the job listed in our results in this case. It looks like there are plenty of jobs with agencies. Are there any jobs without agencies? Let me just see. So this is on the right side, our agencies column. Let me just take a quick scan and see if there are any missing. There's a way to do this more programmatically in SQL. So let me just see. Okay, so I didn't see any missing, but let's take another look using actual SQL for what it's good for. I can say the same thing, do a left join with the agencies, but only find those agencies, or sorry, those jobs that are missing the agency, where, and apply an additional filter. So I'm joining the jobs with the agencies if they exist, but they may not. But now limit it to only those where it doesn't exist, where agencies dot whatever the primary key is, let's say ID, is null. That's how you check against the null value. So I'm saying match up jobs with their agencies. Some agencies may not exist, and only show me the ones that don't exist. That's what I'm saying. None in our data set. Let me add one in so we can play with that. So insert into jobs in the fields title, salary range from, or sorry, title and agency ID, and salary range from, let's not even worry about salary range from, I'll just keep it quick. I'm going to insert a new job, just the title and the agency ID, the values, make believe job with no agency, and the value 99,999. I don't think we have that many agencies, so that should be safe. So I'm putting in nonsense data that's missing. It's referencing an agency in the agency ID field that is not really going to be there. Not null constrained. I applied a constraint when I made the table, which said that the job ID must not be null, so I apologize. Into jobs, job ID, and we'll give it a nonsense job ID. 1, 2, 3, 4. Hopefully that's not used. Oh no. So when I made the table, let me just show you the code I used to make the table. I was being thorough, and I included this statement, not null. That implies there's a constraint on this data. I have to put in, when I insert a new record, I have to put in, of course, the primary key, which has to be there because that's the unique value, but also each of these fields I've specified has to be not null. That prevents you from getting data that's missing in your table. So I unfortunately did that. Let me just put in all those fields. So agency ID, salary range from, salary range to. And so I'll put in the data of the title, the agency ID, the job ID, and the salary range 20,000 to 30,000. All right, now it's happy. So now if I do that query, again, that left join, where is it? The left join that shows me all the records from the jobs table matched up with their agency, but only those where the agency ID is null, meaning does not exist. There's no reason why the agency ID shouldn't exist, except that that record just doesn't exist. Agency ID is the unique primary key for every record. So if that's null, that means that record is not in existence. And there we have it, make-believe job with no agency. So I've now found that there is a non-referentially integral record in my data set. There's an orphaned job, essentially, a job that doesn't have an agency of any real kind that it belongs to. So let me show you, now that we have a data record in our jobs that does not match actually a record in the agencies, because I manually added this one in there, let me just show you the left join, the regular left join with showing all results and their matching agencies. So select star, I'll do all fields, from jobs, inner join, agencies, on jobs, agency ID is agencies ID. They're the same, they match. And semicolon. So you will not see the make-believe job with no agency show up because I'm doing an inner join. An inner join will only match records that have relationships, where the jobs result matches a record in the agency's results. So if we just quickly scan these, there might be a lot of records here, so maybe I won't look through all of them. But if I looked through, trust me, I won't look through the whole thing. Trust me that that job will not appear. And that's because, again, that's because we did an inner join. I'm looking for jobs and their matching agencies on this relationship that will only include results that actually are present. If I did left join instead, as we were just saying, that referential integrity constraint is no longer present in my query, and I will see that job show up somewhere here. Let me just see if I can actually find it. Okay, there it is right there at the bottom. So, so you see that that actually has shown up. This is the record with the new make-believe job with no agency. The agency ID field, which would normally be the third field, I think, is there in the jobs table, right? That's the third field. But the other field, this is actually the agency ID field that I've merged together because I've done a join with all columns. This is the agency ID field, actually has nothing in the results here. Actually, it would be right here. So there's no matching agency ID. That's because I'm doing a left join, and I can do this. I can do a left join that shows me results that don't have a match. Why is it called left join? Let me just get into that terminology before we're getting near the end here. So you can do left joins or you can do right joins. What is the difference between a left join and a right join? By the way, there are two ways you can do outer joins, left or right. Inner join is this referential integral join. Two kinds that don't have referential integrity, left and right. What is a right join? A right join would use the rightmost table, and that is really when we're talking about the table names. Look at the word right join. There's a table name on the right of it and the table name on the left of it. Right? That's what we're talking about when we're talking about left or right joins. Which table name are we referring to first? In this case, or earlier, I should say, when we did left join, that tells SQLite or any SQL database that this table is the table driving the results. What we mean by that is that the database will go through every record in the jobs table first and match it up with its, if there is such a thing, with its corresponding agency result. Remember that with a left join, there may be missing agencies, but it will go and try and find the matching agencies result and merge the two. But it'll first look for the job for every record in the jobs table and then match it with its corresponding agency. If there is an agency that doesn't have a job associated with it, it won't show up in a left join. Let me just make that super clear. I'll insert a new agency that doesn't have any jobs. Insert into agencies in the fields ID, or not just title, values. What's our new agency name in government? The Department of Printer Ink. There we go. Thank you very much. So we're putting in a new agency. There are no jobs in that agency, right? Let's just take a look. Select star from agencies. Department of Printer Ink has been automatically assigned ID number 43. If I do select star from jobs where agency ID equals 43, are there any jobs in that agency? Of course, there are none. We have not added any, right? So let me show you the left join. Again, select star from jobs, left join agencies, on jobs, agency ID matches the agency's ID field. And let's take a look at that, where filter by only those jobs, well, there are none. So let me just leave it like that. Now, we said that this doesn't maintain referential integrity. Left join, right join do not maintain referential integrity. If I did a simple left join query like this, where I'm joining the jobs to their agencies with a left join, it will take every job that does exist in the jobs table and match it up with the agency if that exists in the agencies table. It does not take all the agencies, whether or not they have a job associated with them, and include all agencies in the results. Right? Do you see the difference? So it will include all jobs and optionally their agencies, but it won't include all agencies, including those that don't have jobs. So it only works in one way, really. The lack of referential integrity only works in one way, from left to right. We are looking at all existing jobs and optionally their agencies. With a right join, it's the opposite. With a right join, I would be saying, look at all the agencies and match them up with jobs optionally. But I will get all the agencies, including those that don't have jobs, including those that have null values in their job section. Sadly for you, there is no such thing as right join in SQLite. This actually would work perfectly fine in most other SQL-based databases, but SQLite does not support right joins. So there would be no way I could just say, oh, go look at the agencies table and optionally whatever jobs are matched. I can do left joins. I can say, go look at jobs. Well, how do I do a right join? Well, it's simple enough. You take what is a left join and you switch the order of the table names. Agencies comes first in this case, jobs comes second, and now agencies is my driving table. That's the table that will be looked at, and every record will be matched with a corresponding job. And here I will get Department of Printer Ink, but of course there are no results for that. We've reached the end of essentially where we're going with the big picture ideas. Well, we've got inner joins, left joins, and right joins. Inner joins, you match a table to its corresponding records in another table only where those matches exist. Left joins, you use the left table that's mentioned first in your query, look through all the records there, match to, if possible, matching records in the right table. Right join, which you can write in SQLite, but in a left join way, take the results from the other table and match them optionally to matching results in the first table. So again, with right joins in SQLite, just bear in mind, you just reverse the order of the table names. Now, what used to be the right table becomes the left. What used to be the left table becomes the right. So you can do a right join. It just requires you to remember that you flip the table names and use left join. Quiz question, how would I find how many jobs exist in each agency? All right, so selecting how many values there are in the title field from the jobs table when you group all the records by agency ID. This looks pretty good. However, you're going to get numbers that mean nothing to you. This is the correct number of jobs per agency, but we don't see which agency is which. How do we solve that? An agency ID, let's say. Let's just start there. We're still only dealing with the jobs title, the jobs table. So I'm going to show you the agency ID and how many jobs there are in each. So agency ID 0 has 62, agency ID 1 has 141 jobs. That's all good. This is the right data, but it would be nice to see the title of each agency, wouldn't it? In this case, where I'm trying to get you to think is we can't do that with just one table because the jobs table doesn't have the title of the agencies. So in order to show you the agency title, I've got to join the jobs table to the agencies table so I can get, for each of these records, the title of that actual agency. Jobs.agency ID is matched to the agency's ID. All right, so I've now got the merger working. That is correct, I believe. So I've joined the jobs table to the agencies table, maintaining referential integrity because I only want to count jobs that exist. And I'm actually counting jobs in each agency, so those agencies also have to exist. And I'm looking for the match on the foreign key primary key, like we almost always do. And I'm just going to select not only the count of the jobs, but now the title of the agency. So this would be agencies.title. Now that I've included the agencies table in these results, I can pick out the title of each agency. And there you go. Let's order them. Why don't we order them? Order by, and I want to order by how many there are. So I want to see the agencies with the most jobs at the top with the least jobs at the bottom. You can treat this like a field name. Count jobs title. So really what you're doing with a query is you're kind of in the memory of the database creating a temporary table, and I can sort by these temporary fields that I've created with some of these function calls. So I'm going to order by the results of that query. And let's order in descending order. The most job openings in agencies are at the top. Housing authority is really pumping. You've got mental hygiene as well, health and mental hygiene. I guess in coronavirus times, that is a super important one.